All right, today we're going to put on our detective hats. Why? Because we're tackling a planet-sized mystery, the story of life on Earth. Our job is to follow the clues, piecing together a history that goes back millions and millions of years. So, let's get this investigation started. So, here's the big question that kicks everything off. You look around at all the incredible plants and animals today, but how do we know it was always like this? How can we be so sure that it all didn't just pop into existence at once? What evidence actually tells us that life has changed, that it's evolved? To get to the bottom of it, we're going to follow three major lines of evidence. Think of them as three distinct clues. And when we put them all together, you'll see they paint a really clear and compelling picture of life's history. Let's start with clue number one. Our first clue takes us deep, and I mean literally deep, into the Earth's crust. We're talking about paleontology, the story of ancient life that's written in stone. The key pieces of evidence here, fossils. Now, these are so much more than just interesting rocks. They're actual, tangible echoes from the past. These are the real remains of organisms that lived and died millions of years ago, perfectly preserved for us to find. What's so amazing is how these fossils are organized. They create a timeline in the rock itself. Just picture it. For eons, layers of sediment, like sand, mud, and silt, have been piling up one on top of the other. The deepest layers are the oldest, and they hold the most ancient fossils. And as you move up toward the surface, the layers get younger and younger, revealing this clear, step-by-step progression of life through time. And this incredible timeline shows us a few absolutely crucial things. It proves that life wasn't static. We see that different creatures, like the dinosaurs, lived in very specific eras, and then, poof, they vanished. It shows, without a doubt, that new forms of life have appeared at different moments in Earth's long story, not all at once. Okay, for our next clue, we don't have to dig into the ground at all. We just need to look really closely at the life that's all around us today. We're looking for a kind of shared family blueprint. This brings us to a really cool concept called homologous structures. Now, that sounds a bit technical, but the idea is simple. It's when you find different animals that have anatomically similar body parts, even if they use them for completely different things. It's like they're all working from the same original design, just with a few tweaks. And here is the classic example. Take a look at the forelimb of a human, a cheetah, a whale, and a bat. One is for grasping, one for running, one for swimming, and one for flying. Totally different jobs, right? And yet, they are all built from the exact same set of bones. The only way this incredible similarity makes sense is if they all inherited this basic bone pattern from a shared ancestor way back in the past. Now, just to make sure we've got this, let's look at the opposite idea, analogous structures. This is when organisms have body parts that do the same job, like flying, but have totally different anatomical origins. Think about the wing of a butterfly versus the wing of a bird. Same function, but a completely different build. So here's the bottom line. Homology, with its shared anatomy, points to a shared past. That's divergent evolution, starting from one point and branching out. Analogy, on the other hand, points to a shared problem. That's convergent evolution, where different branches of the tree of life arrive at a similar solution all on their own. And you know, this common blueprint isn't just in bones. Scientists see these same exact patterns all the way down at the molecular level. When you look at the similarities in essential proteins and genes across wildly different species, well, that's just more evidence, all pointing back to the same shared family tree. So our first two clues came from the past, one from the deep past, one from the more recent past. But what if I told you that our final clue is happening right now? This is where our detective work gets really exciting, because we get to see evolution in action with our own eyes. For this, let's take a quick trip to 19th century England and talk about the famous peppered moth. This is just a fantastic real-life story of natural selection caught in the act. Okay, so before the Industrial Revolution, the trees in England were covered in this light-colored lichen. So as you can see, the light white-winged moths were thriving because they were perfectly camouflaged. The dark-winged moths, on the other hand, they really stood out, making them an easy snack for birds. But then, the factories started churning out tons and tons of soot. It killed off the lichens and stained the tree trunks black. In a very short time, the entire environment changed. And by 1920, the tables had completely turned. Look at that. Now, the dark moths were the ones with the perfect camouflage. And they flourished. The white moths? Well, they stuck out like a sore thumb against the dark bark. The population shifted dramatically. That, my friends, is natural selection. So that was 100 years ago. You might be wondering, does this kind of fast-paced evolution still happen? The answer is a resounding yes. In fact, more often than not, we're the ones causing it. Scientists call this evolution by anthropogenic action, basically evolution driven by humans. Think about it. Every time we spray herbicides, we're unintentionally selecting for the absolute toughest weeds. When we use pesticides, we're selecting for the most resistant insects. And most critically, our overuse of antibiotics is driving the rapid evolution of drug-resistant bacteria, not over centuries, but in just a matter of months or years. So our investigation is coming to a close. We've examined the clues from the stones, we've looked at the blueprints inside living things, and we've seen evolution happening in the world around us. So what's the verdict? The scientific verdict is clear, and it's so powerful because all the clues converge. They all point to the exact same conclusion, but from completely different, independent directions. The fossil record gives us those echoes from the past. Comparative anatomy reveals that shared blueprint. And we can literally observe evolution happening in real time. And this leaves us with a really profound final thought. Evolution isn't some kind of planned march toward a predetermined goal. As all this evidence shows, it's a process built on chance, on random mutations and unpredictable events in nature. It's a constant, creative dance between life and its ever-changing world, a story that is still unfolding right before our eyes.